Yeah, good evening. I welcome you all for another an excellent presentation on control system subject in which we are discussing about the concept of stability. We are discussing from the last two or three presentations onwards. We have seen the concept of stability means what is the stability, and the stability of the given control system can be estimated by with the help of two important techniques, namely the first one as the RH criteria, that is Ruth Hurwitz criteria. That is the first technique by which we can estimate the stability of the given system, and after that we will see the root locus method or the root locus technique. These are the two very important techniques will be applied for the given control system to determine its stability, right? If you recall our previous presentation, that is lecture number 57, there I have already given you the problem, right? By the way, today we are going to continue the same previous problem in our today's presentation, that is lecture number 58. This is the one important question that has been asked in IAS 1999 on this particular stability concept topic, right? So in this example, if you see the elements of the first column of Ruth array, see that the first column elements of Ruth array are given by like this. These are the elements 3 comma 5 comma minus 3 by 4 comma 1 by 2 and 2. These are the elements given. It means that the question is, it means that I already given in the options in the previous presentation. Let us go to the previous presentation, which is available under lecture number 57. There I have given what are the options. There are four options given actually, because I will not write again here because it is already there in lecture number 57. You please refer that, right? So what it indicates actually, if the question is, if the first column elements of the Ruth array given by like this, then it shows what actually, that is the question. It means that what, which is nothing but there are the options actually. Your first option is one root in the left half of the S plane. That means that the given control system has one root on the left half of the S plane. Your option B is there are two roots in the right half of the S plane. Option C is there are two roots in the right half of this plane. B is actually there are two roots in the left half of this plane. You please refer the previous presentation, that is lecture number 57. I have already noted down the problem. You can see that options from there. And now in this presentation, now I will explain you the answer. This is the question based on the sign change concept. In the beginning presentation of this RH criteria, I have explained you that if or otherwise you can say, I can write basically, definitely how many coefficients are there? 1, 2, 3, 4, 5. Remember that this is s power 0 coefficient. This is s power 1. This is s power 2. This is s power 3. This is s power 4. So the Ruth Hurwitz criteria or the RH array you can write like this: s power 4, s power 3, s power 2, s power 1, s power 0, right? Then draw a line there. Now you can represent that like this. These are the first column. Column means the first is 5. This is second is 5. Next is minus 3 by 4. Next is 1 by 2. And then it is last is 2. This is the meaning of the question. If you put the given elements in the Ruth array, this is what your Ruth array, this is called Ruth array. This is called Ruth array. if you represent those elements in the root array, you must represent like this. This is the meaning of it. This is the first column elements. So what it indicates actually, see that what are the conditions required in order to comment on the stability of the given system. What is the first and foremost condition? That all the elements of this first column in the root array must be positive, means must be greater than 0. They must be greater than 0. That is the first condition, right? And the second condition, okay, that is the first condition. See that here here if you see, there is one negative value is there, minus 3 by 4. Minus value is there. There should not be minus. If minus is there, remember that it is a unstable system. It is not a stable, because there should not be minus. Where is fundamental note that everybody should remember it. Okay, there should not be minus in the first column. All are must be positive and greater than 0 values must be there in the first column. That is the first question, the first note or first point. And if you see here minus is there, 3 by 4. Minus is indicates less than 0. Therefore, it is a negative. What it indicates actually? Let us see. So, what is the sign of 3 here? If it is nothing is not given, the sign is plus. What is for 5? The sign is plus 5. It is minus 3 by 4. However, 1 by 2 is plus, and 2. What is the sign for 2? It is plus. Clear? These are the signs. Now, see that here this number, this element to this element, this is positive sign, positive sign. Is there any change is there? No, because plus to plus, no sign change. Because similar sign is there, same sign otherwise. Both are positive numbers. Therefore, no sign change there. Now, come to the element 5. 5 to minus 3 by 4. Here sign change is there. So, plus change to minus here means plus to minus. One sign change is there. Between 5 to 3 by 4, you have one sign change here. You have one sign change here. Similarly, minus 3 by 4, this minus to plus, there is another sign change. This is the another sign change. And again, this is again 1 by 2 to 2. Here plus is there, again plus is there. Plus to plus, it is plus to plus, therefore there is no sign change. Clear? So, therefore, here plus to minus, we have one sign change. That means one sign change is there. And from minus to plus, another sign changes. So, how many sign changes are there? 2 sign changes are there. There are 2 sign changes. You can write also for your understanding. There are 2 sign changes. There are 2 sign changes. So, what it's mean? There are 2 sign changes are there. What it indicates? The number of sign changes indicates how many? 2 sign changes are there. The number of sign changes indicates the number of roots which are lies on the right side of the S-plane. Right side of the S-plane. Right? Clear? Therefore, the number of sign changes indicates the number of roots that are lying on the right side of the S-plane. Therefore, as far as this problem is concerned, 2 sign changes are there, means 2 roots are there on the right side of the S-plane. That is the, if you see the option, your option C, if you refer my previous presentation, there if you see the option which is given for C, option C, there are 2 roots in the right half of the S-plane. Your answer C is correct actually. There are 2 roots. This is your option C. There are 2 roots in the right side of the S-plane or RH side. No problem. Right side of the S-plane. That is the answer. C is the option C is the correct answer for this question. Right? That is the answer. Clear? So likewise, these type of questions will be expected. Is already asked in IAS examination. Similar can be expected in your GATE examinations also. I think you understood this problem, right? So this is how we have to comment on that. Therefore, there are 2 sign changes or simply it is not required to write all these things in the competitive examinations. For your understanding, I just given the root array and how the sign changes will be identified and how we can comment on the number of roots that are there on the right hand side of the S plane. Or otherwise, simply by seeing these particular elements also, as we have one sign change here, I mean one negative sign you have it. Therefore, obviously, before 3 by 4 plus 5 is there. Therefore, plus 2 minus 1 sign change, minus 2 plus another sign change, only 2 sign change. Therefore, 2 roots are there on the right side. That's it. That's it. So that is one type of question. And also, if they asks that, if the elements are given like this, now comment on the stability. Is it stable or unstable? Tell me. If the elements are given like this, they will asks you that whether it is stable or definitely it is unstable system, because there should not be any negative. There should not be any negative, right? There should not be any negative. If negative is there, it is unstable, and definitely it is a question on unstable. This system is unstable system, in fact. That is one thing, right? I think you have understood this. Okay, and I will finish off this presentation here, and I will explain you the another remaining beautiful examples in the next subsequent presentations. I hope you understood it very well, and I thank you all for watching this, and we'll see you in the next presentation. Have a beautiful day.